Welcome to Maths for All. I'm Aisling Flynn. This is exam practice. This is a question from a paper 2, mostly based in trigonometry with some length and areas thrown in. Okay, so first off we're given a big story alongside a diagram. So let's read the story and try and match it to the diagram. R is a radar station located 120 kilometers north of a port P. The circle C, centered at R with radius 100 kilometers, shows the detection range of the radar. When a ship enters the circle, it will be detected by the radar station at R. So what do we have? We have points P and R 120 kilometers apart. We have a circle with radius 120 kilometers, which is centered at R. Okay, so figure 1 shows a ship leaving the port P and sailing in the direction north 30 degrees east. Okay, the ship enters the circle C at S and exits at T, so it passes through the circle. At Q, the ship is closest to R, and the angle PQR is 90 degrees, so that's also shown there. Angles are named from and to, so from P to Q to R, so the point of or the vertex of the angle will be at the middle letter Q, and right there it is 90 degrees. So question A, the triangle PQR taken from figure 1 is shown in figure 2. Okay, find QR, the length of QR. So when these parallel lines are shown, it means the size or the magnitude or the length of. So we're looking for this length of this line from Q to R, and I think for simplicity we'll call it X. Okay, we know that we have 90 degrees at Q and that the angle at P is 30 degrees. So it's very helpful, as is already done for us here, to lift the triangle in question out of the main diagram. Okay, it makes everything look a little bit more simple. We're focusing on this one little triangle only, and as you can see, this is a right angle triangle and we're trying to find a missing side, X. Okay, now because we have a right angle triangle, we have a number of tools at our disposal. So right angle triangles, well, the first one is Pythagoras Theorem. So can we use Pythagoras Theorem to find X? Well, Pythagoras Theorem needs us to have our unknown, which is X, but we need the other two sides. And in this case, we don't know the other side to be able to calculate using Pythagoras Theorem. So that's out. What else do we use for right angle triangles? Well, we use our three ratios. The sine of an angle is the opposite over the hypotenuse. Cosine of an angle is adjacent over hypotenuse, or the tan of an angle is opposite over adjacent. Okay, so perhaps we can use one of these. Now, which one is the question? Well, that depends on what we have and what we want to know. Okay, so what we want to know is X, and what we have is the angle 30 and 120. So we need to do some labeling here. If I stand in the angle 30, straight across from me is X, that's known as the opposite side, or O. So I want to know the opposite. What else do I have? We've already said we don't know P to Q, that's the adjacent, so that's no good. We also know the hypotenuse, H, okay, across from 90 degrees, the longest side. So which of the three ratios uses opposite and hypotenuse? Opposite and hypotenuse, well, it's the sine. Okay, we have over H. So we're going to fill in what we want to know and what we have. Okay, so sine. Now theta is used here as the angle. Do we know the angle? Yes, we do. We know it's 30 degrees, so we can fill that in. Now opposite. X is opposite, so we put X over our hypotenuse, which we know is 120 degrees. Okay, so we do have an equation, all right, and with one unknown, which is x, which means we can solve this. Okay, what I'd like to do here is get rid of the fractions. I'm going to multiply left and right by 120. Why would I do that? Because 120 divided by 120 gives 1, and so I get 120 times sine 30 equals x. So on my calculator I'll solve that. 120 multiplied by sine 30, I get 60. So 60 equals x, or as was asked in the question, the length of QR equals 60, and it will be kilometers because the 120 was in kilometers. Actually, there shouldn't be degrees sign there at all. Okay. All right, so QR equals 60 kilometers. So did we get it right? Yes, we did. 15 marks going for that. Low partial credit, so 5 out of 15 if you did work of some merit, or if you wrote down the correct trigonometry ratio. Okay, you get 5 out of 15. You get 9 out of 15 if you substituted the formula correctly. If you made one mistake and finished otherwise correctly, or if you had an incorrect calculator mode. Okay, so if you were not working in degrees, if you had your calculators in the wrong setting to radians or something. Okay, so always check that at the start. Now, part B. The triangle QRS taken from figure 1 is shown in figure 3. Use your answer from part A to find QS. Okay, so we're told R to S, which was a radius, is 100 kilometers. Use our answer from part A, so that was for Q to R, and we found that that was 60 kilometers. And now we have to find the length of QS. Okay, so maybe we call that X this time. Okay, so again, we have a right angle triangle, and in the toolbox are Pythagoras Theorem and the three ratios. Okay, now in this case we don't have any angle, we have no theta. Okay, we don't know. So the ratios are out, and we're going to see if we can use Pythagoras. I think we can because we have two of the other sides. Okay, so write it down for the examiner. Now, what number to put where? Well, C on its own on the left hand side is always the hypotenuse, and the hypotenuse in this triangle is across from 90 degrees is 100. So we'll have 100 squared equal to, now the one we don't know we'll call x, so x squared plus the other side is 60 squared. Okay, so we should be able to solve this. So I'll have, what's that, 10,000 equal to x squared plus 3,600. X squared will be, we'll take the 3,600 from both sides. Okay, will be equal to 64,000. Is that right? Get my 6,400. Get your zeros right. Okay, so x will be the square root of that. So you'll find that x is 80. Or as asked in the question, find QS. So the length of QS is equal to 80 kilometers. All right, let's see, did we get that right? Okay. Yes, we use Pythagoras Theorem. All right, now you don't have to write out all these letters. You can do it just as we did. Okay, and we got the right answer. So there were 10 marks going for that. 4 out of 10 for a work of merit, or if you wrote down Pythagoras with some substitution. 6 out of 10 if you fully substituted into Pythagoras, or if you didn't quite get to the end, if you had the square root of 6,400. Okay. So part C says find the length of PS. Give your answer correct to the nearest kilometre. So I think we need to look at our diagrams again. So figure 1 is here. PS is this short distance from P to S outside the circle. Now I think we can probably use some of our answers from previous parts. So recall that we found that the length QR was 60 kilometres. And from Q to S was 80 kilometers. Okay, so what we didn't find, however, was S to P. Okay, let's look at the triangle in figure 2 a bit more closely. Okay, so we know that this one here now is 60 kilometers. We don't know the total length from Q to P, but if we could find that out and take away the 80, which is from Q to S, okay, then we would be able to find our P to S. So that's what we're going to do. I think we're going to use Pythagoras again. All right, let's write it down. C squared equals A squared plus B squared. Now the hypotenuse across from 90 degrees is again 120, or it's 120 this time. Okay, and let's call the total length from Q to P, let's call it X. Okay, so that's my X squared plus the other side squared, which is 60 squared. Okay, so squaring out the numbers, we get, 144 with 2 zeros equals X squared plus 3600. Let's subtract 3600 from both sides, and we get X squared equals 10,800. Okay, now to solve for X, we'll get the square root of that. And I get 103.923, and it goes on a bit, kilometers. Now we're told to give your answer correct to the nearest kilometre. Well, we get for here, actually we're not finished yet, we get 104 kilometers. Okay, now that wasn't the answer we were asked from PTS. This equals the length from P to Q. Okay, so we're going to take our 104 kilometers, we're going to subtract 80 because that was from S to Q. So just for yourself, that's the length of PQ minus the length from S to Q, or QS in reverse. Okay, and so we get the length of P to S equals 24 kilometers. Now here's the marking scheme. We got our 103.92 there, okay, and then we subtracted and we got 24. Okay, 10 marks going for that. 4 out of 10 for any work of merit, or if you use Pythagoras with some substitution, or if you wrote down what you hope to do to subtract the distances, you get 4 out of 10. You get 6 out of 10 if you fully got Pythagoras and got the PQ evaluated. But if you forgot to do the subtraction at the end, you'd still get 6 out of 10. Right, part D. Consider the triangle RST. So it's shown there in the diagram. Use the cosine rule to find an expression for cosine theta, where theta is the measure of the angle TRS, and hence show that theta equals 106 degrees correct to the nearest degree. Righto, so lots to do there. First off, it's mentioned the cosine rule. I think we should write it down. So you'll find the cosine rule in your formula and tables books. So you'll have to go to the 4th page of trigonometry in your formula and tables book, it's page 16, to find the cosine rule. Okay. Now you'll see all the other rules there. You'll also see your ratios here, but they don't use O, A and H for opposite, adjacent and hypotenuse as we do. So we're going to start by writing down the cosine rule, which is a squared equals b squared plus c squared minus 2bc cosine A. Now what's A, B, C and big A? Right, so how do we label triangles? So if you're given an angle A, capital A is given to the angles, the side directly opposite is known as small a. Okay, if you had an angle B, the side directly opposite it is known as small b, and the same for C. So it's angles with their opposite sides. So what is angle A in our question? Well, the angle of interest is theta, so that's capital A, and the side opposite that takes small a. Okay, and the other two can be B and C then. Alright, so we're looking for theta, which will be our unknown in the question. So we need to know everything else. Now we know that B is 100 and C is 100. There's B and C. But we don't at the moment know what A is, the length from T to S. And that's a problem. We won't be able to solve for theta if we don't have all the other information. So let's return to our original diagram. Okay, and we're looking for T to S. Alright, so let's look at our triangle TRS. So I'll just add in this line here, and that line I've just drawn is a radius, so it's 100 kilometers. Okay, so actually what we have in the triangle TRS is an isosceles triangle where two of the sides are the same, meaning that two of the base angles there are the same, and also this 90-degree line splits the line T to S exactly in half. Okay, now that's useful because I think it was in part B we found that QS was 80 kilometers. Okay, well that means that Q to T is also 80. Okay, because the perpendicular line splits it right down the middle, and therefore we have the distance from T to S should be equal to 160 kilometers. Okay, which is our A. So now we have all the information required to go ahead and solve for theta. So let's fill in what we have. So A, as discussed, is 160 and that needs to be squared. B is 100, that needs to be squared. C is 100, that needs to be squared. Or that's a minus, should come next. Minus 2 times 100 times 100, that's your B and C, cosine theta. So now we have an equation. Might not look so nice, but we have an equation where there is only one unknown quantity, so we should be able to solve it. So calculators at the ready. 160 squared is 25600, so I always count the zeros in case I add or drop one by accident. Next we have 10,000, that's 1 and 4 zeros, and same again. Minus 2 times 100 will give you 20,000, 2 and 4 zeros, cosine theta. So now we just have to simplify and manipulate this around to get cosine theta on its own. Okay, so let's add the two 10,000s and we get 20,000 minus 20,000 cosine theta. Let's now start to isolate the cosine theta. We're going to take 20,000 from both sides. Okay, and we get 5,600 equal to minus 20,000 cosine theta. And now we're going to divide both sides by minus 20,000. Count your zeros. Okay, and I get cosine theta equals, and we can put that down here as well in a moment, 5,600 divided by minus 20,000, and I get minus 7 over 25, and I put that down in the answer space below. Okay, so that's cosine theta, or you can use the decimal version if you want. So lastly, we've been asked to find theta, or to show that it's 106 degrees. Okay, now how do we do that? If you know the answer for cosine theta, you can work backwards to see what angle of what degrees gave you the answer of minus 7 over 25. Alright, so I'm going to get my angle should be equal to, and we use the inverse function, so going backwards. So use the shift and the cosine on your calculator to give you inverse cosine, and type in minus 7 over 25. And press equals, and we get 106.26 degrees, and it's set to the nearest degree, so we'll put down 106 degrees. Okay, so pause that, go back through the process, especially where TS came from. Okay, that was a catching point in this question. Let's look at the marking scheme next. Okay, so did we get 160 degrees? Yes, we did. Here's our cosine rule substituted correctly. We got our minus 7 over 25, and we got our 106. Okay, so look at that. Only 5 marks, and it was by far the most difficult part of the question so far. All right. What it says to me is that when it came to marking in the Leaving Cert, a huge number of people didn't do very well in it. Okay, so that means if you get your basics right, your parts A, B's and C's, you're going to get the vast majority of the marks from the whole question. Okay, and then everything after that is a bonus, so give it a go. There's partial credits all over the place here. You get 2 out of 5 if you wrote down the cosine formula with some substitution. You get 3 out of 5 if you use the cosine formula with 2 variables. So if you got your B and your C in, so say you didn't figure out to A, you might still have gotten 3 out of 5. You get 4 out of 5 if you substitute it into the formula fully correct. Okay. Or if you got 1 wrong but you did everything else correctly. Okay, and you got no credit if you treated the triangle as a right angle, if you use sine, cos or tan. Okay, so the next part of that says that John sailed directly from S to T. Mary sails from S to T along the minor arc ST. Find the difference between the distance that John sails and the distance that Mary sails. Give your answer correct to the nearest kilometers. Okay, so what's going on here? So John went straight from S to T, right? And we know from the previous part that that's 160 kilometers. Mary sails from S to C along the minor arc. Now an arc is a part of the circle, and minor means it's the smaller one. So from S you could go right or you could go left, right? So the minor one is the smaller one. So from S to T, so along here is where Mary went. So this was John, 160 kilometers, and this was Mary. She went in a curved direction, which means she's going to have a longer distance. Find the difference between their distances is the question. Okay, so how do you get the length of that arc? Well, let's see. If you go to your formula and tables book, you have some information about arcs here. Okay, and we're looking for the length L, and L is equal to, if we're in degrees, which we are when theta is in degrees, is equal to this. All right, now what's that? Well, it's the length of a full circle, 2 pi r, multiplied by what fraction of the circle you have, so whatever your angle is out of the full circle. All right, so let's see that in work here. Alright, so we were told that L equals 2 pi r is the perimeter or the length of a full circle. Multiply by, well, what fraction of a full circle do we have? We know there's 360 degrees in a full circle. We only have 106 degrees, so we don't have the full part. Okay, so we will multiply 2 by pi. Well, we can use 3.14. You can use the pi function on your calculator. Multiply by r. Well, the radius of our circle is 100 kilometers. Okay, multiply by, well, what fraction of the circle do we have? We have 106 degrees out of 360. Okay, so take your calculator. You're going to multiply all the numbers on the top line. 2 times 3.14 times 100 times 106. Okay, and then you're going to divide that answer by 360. So I get 184.91 kilometers. So that was Mary's distance along the curve, and we're asked to find the difference between hers and John's. So we'll take 184.91 and we'll subtract his distance, which we saw in the last part was 160. And we get 24.91 kilometers. Correct to the nearest kilometer, we'll say 25 kilometers in the difference. Let's check our answer. Well, we got it right. Okay, so we have to use the formula here for the arc, which we used. We used the correct radius. We used the correct fraction. Okay, and they used a different answer for, or value for pi, which gives them slightly different here, but it all worked out the same. Okay, there's 10 marks going for that. You get 4 out of 10 if you use the arc formula with some substitution, or if you refer to the fraction of the circle. You get 6 out of 10 if you got the arc length correct but didn't keep going to subtract. Okay, part 3 then. The sea in this region is estimated to have an average of 1 ship per 25 square kilometers at any time. Use this estimate to find the number of ships in the sector, or ST. Give your answer correct to the nearest whole number. So we're talking about ships per square kilometers. So that tells me straight away we're talking about areas. Okay, so it gives us 1 ship per 25 square kilometers. Basically, we need to find the area of this grey sector, and we'll use our area formula for a sector. So back to our formula and tables page. So we're looking at a sector, and we're looking for the area, which is A, when we're using theta in degrees. So it's this one. Again, it's based on a full circle. The area of a full circle is pi r squared. And then we're going to multiply it by what fraction of a full circle we have. Okay, so let's try that. We get area equals pi r squared would have been for a full circle, but we don't have that. We'll multiply it by what fraction of a circle we have. Remember, our angle is 106 degrees. So again, pi 3.14, if we go another decimal place maybe, would be match up better, by the radius, which is 100 squared, by what fraction of a full circle do we have? 106 divided by 360. Okay, so again we're going to multiply all the numbers on the top line. We'll show it this time maybe. 3.142 by 100 squared by 106. That would give me a really large number, 3330520. Just check that number and make sure you've done it correctly. Divided by 360. And we'd get 9,251.4, and there's a dot on the 4. What does that mean? Means 9251.444 and recurring. Okay, so that's the angle or the area of our sector, but that's not the answer to the question. We're asked how many ships. We're told that there's one ship per 25 square kilometers. Our area is in square kilometers, so we're going to divide this by 25. So divide that by 25 and it'll tell us how many ships we should have. So I get 370.057 with a dot on it. So it said correct to the nearest whole number because we're counting ships. You can't have 0.057. Alright, so I'll say 370 ships. Okay, let's check our answer. So area of the sector, yeah, we did that correctly. We used the right formula and we got 370. And look again, there's only 5 marks going for that. Alright, you get 2 out of 5 if you had the formula with some substitution. So always write down the formula, always try and substitute some numbers. 3 out of 5 if the formula was substituted correctly. 4 out of 5 if you got the area of the sector but you forgot to finish with the number of the ships. Okay, and if you did everything more or less right but you made one mistake, you get 4 out of 5.